Greenland, a land of ice and snow where the vast expanse of white stretches as far as the eye can see. This place is a realm of breathtaking beauty, where towering icebergs and majestic frozen scenery create a landscape like no other. But beneath this pristine facade, a silent threat emerges, one that could alter this frozen paradise forever. Scientists have made a startling discovery. Algae are growing on the Greenland ice sheet and they are accelerating its melt. These tiny organisms, often overlooked, are having a massive impact. This revelation has sent ripples through the scientific community, raising concerns about the future of this icy giant. Researchers are now racing against time to understand the full implications of this phenomenon. For years, scientists have known that Greenland's ice sheet is shrinking. The evidence is clear in the time-lapse images showing glaciers retreating and ice sheets diminishing. What they didn't fully understand was the role of these tiny organisms in this process. Algae, which are typically associated with oceans and lakes, have found a home in this unlikely environment. Algae, typically associated with oceans and lakes, have found a home in this unlikely environment. Their presence is not just a curiosity, it is a game changer. Their presence is changing the very color of the ice with profound consequences. The dark patches they create absorb more sunlight, leading to faster melting. This discovery has added a new layer of complexity to our understanding of climate change. Scientists are now delving deeper into how these algae interact with the ice and what it means for the future. It highlights the interconnectedness of our planet's systems and the far-reaching impacts of human activities. The algae on Greenland's ice sheet are a stark reminder of how even the smallest organisms can have a significant impact on our environment. The fate of Greenland's ice sheet is intimately tied to the health of our planet, and the presence of algae serves as a stark reminder of the challenges we face. As the ice melts, it contributes to rising sea levels, which can have devastating effects on coastal communities around the world. Coastal flooding, erosion, and the displacement of communities are just some of the consequences of rising sea levels. The melting of Greenland's ice sheet is not an isolated event. It is a global issue that requires immediate attention. Scientists and policymakers around the world are now collaborating to address this urgent issue. International climate conferences and global efforts to combat climate change are more critical than ever. The fight against climate change requires innovative solutions and sustainable practices. Renewable energy sources such as wind and solar power are essential in reducing our carbon footprint and slowing the rate of global warming. Community initiatives and environmental activism also play a crucial role. People around the world are coming together to make a difference, from reducing plastic waste to planting trees and advocating for policy changes. There is hope for a healthier planet, but it requires collective action and a commitment to change. Educating the next generation about the importance of protecting our environment is vital for ensuring a sustainable future. As we look at Greenland's icy landscape, now marked by the presence of algae, we are reminded of the delicate balance of our planet's ecosystems. The work of scientists in the field is crucial in understanding and addressing these changes. Protecting our planet is a shared responsibility. It requires global unity and a commitment to preserving the natural world for future generations. The green thread on white ice is a call to action for all of us. Greenland's beauty is a testament to the wonders of our planet, and it is worth fighting for. Together, we can work towards a hopeful future, where united efforts to combat climate change can make a real difference. The story of Greenland's ice sheet and the algae that threaten it is a powerful reminder of the challenges we face and the importance of taking action now. The future of our planet depends on it. Algae, in their aquatic habitats, are essential to life. These tiny organisms, often overlooked, play a crucial role in maintaining the balance of aquatic ecosystems. They are the unsung heroes of our water bodies, providing sustenance and oxygen to countless marine creatures. They form the base of the food chain and produce oxygen. Through the process of photosynthesis, algae convert sunlight into energy, releasing oxygen as a byproduct. This oxygen is vital for the survival of fish, invertebrates, and other aquatic organisms. But on the Greenland ice sheet, they play a different role. Here, algae are not just passive inhabitants. They actively influence the environment in unexpected ways. The culprit is their color. Algae contain pigments that are not just for show. These pigments, especially the dark brown ones, have a significant impact on their surroundings. Algae contain pigments, primarily a dark brown one, that absorb sunlight. These pigments are essential for photosynthesis, the process by which algae convert sunlight into energy. Without these pigments, algae would not be able to harness the sun's energy effectively. These pigments are essential for photosynthesis, the process by which algae converts sunlight into energy. Photosynthesis is not just a survival mechanism for algae, it is a cornerstone of life on Earth. By converting sunlight into chemical energy, algae support the entire aquatic food web. However, on the ice sheet, this absorption of sunlight has an unintended consequence. It darkens the ice surface. The dark pigments in algae absorb more sunlight than the surrounding ice, leading to localized warming. White ice reflects sunlight back into space, helping to keep the planet cool. This reflective property, known as albedo, is crucial in regulating Earth's temperature. Pristine white ice acts like a giant mirror, bouncing sunlight away from the planet. Dark ice, on the other hand, absorbs more sunlight, leading to increased warming. When algae darken the ice, they reduce its albedo, causing it to absorb more heat. This absorbed heat accelerates the melting process, creating a feedback loop of warming and melting. This phenomenon, known as the albedo effect, is a key factor in the accelerated melting of the Greenland ice sheet. The more the ice melts, the more algae can grow, further darkening the ice and perpetuating the cycle. The darker ice absorbs more heat, causing the surrounding ice to melt faster. This increased melting not only contributes to rising sea levels, but also disrupts local ecosystems and weather patterns. This, in turn, creates more liquid water, which further promotes algal growth, creating a vicious cycle of warming and melting. As the ice melts, it forms pools of water that provide an ideal environment for algae to thrive. This growth leads to even more darkening of the ice, accelerating the melting process and contributing to global climate change. The dark side of algae, therefore, is not just a local issue but a global concern that requires urgent attention and action. The harsh conditions of the Greenland ice sheet, with its limited nutrients and freezing temperatures, might seem inhospitable to life. The vast expanse of ice, stretching as far as the eye can see, presents a seemingly barren and desolate environment. The frigid winds and sub-zero temperatures create a challenging habitat where only the most resilient organisms can survive. Yet algae have found a way to thrive. These microscopic organisms have developed unique adaptations that allow them to flourish in such extreme conditions. Despite the cold and the scarcity of nutrients, algae manage to carve out a niche for themselves on the ice. They have adapted to survive on the minimal nutrients available, demonstrating the resilience of life in the face of adversity. Through a combination of physiological and biochemical strategies, algae can make the most of the limited resources at their disposal. Their ability to endure and even prosper in such a harsh environment is a testament to the incredible adaptability of life. One of their key survival strategies is their ability to store phosphorus. This essential nutrient is crucial for various biological processes, including energy transfer and the formation of DNA. By storing phosphorus, algae can ensure they have a reserve to draw upon during times of scarcity. Phosphorus is an essential nutrient for all living organisms, and it is scarce on the ice sheet. The limited availability of phosphorus in such an environment poses a significant challenge for any organism trying to survive. However, algae have evolved mechanisms to overcome this limitation. Algae, however, can absorb and store phosphorus when it is available, allowing them to survive periods of scarcity. This ability to stockpile nutrients gives them a crucial advantage, enabling them to endure the long stretches when phosphorus is not readily accessible. This adaptation gives algae a competitive advantage in this extreme environment. By efficiently managing their nutrient reserves, algae can outcompete other microorganisms that might struggle to find enough phosphorus to sustain themselves. As the ice melts and releases small amounts of nutrients, the algae are ready to absorb them, fueling their growth. The melting process, although gradual, provides a steady trickle of nutrients that algae can quickly take up and utilize. This readiness to capitalize on even the smallest influx of nutrients is a key factor in their survival strategy. This efficient use of limited resources allows them to proliferate, further darkening the ice and accelerating the melt. The presence of algae on the ice surface reduces its albedo, causing it to absorb more sunlight and melt faster. This creates a feedback loop where the melting ice releases more nutrients, which in turn supports further algae growth, perpetuating the cycle. Climate change, driven by human activities, is causing global temperatures to rise. This warming trend has profound implications for the Greenland ice sheet and the algae that inhabit it. As temperatures rise, the melting season lengthens, providing algae with a longer window for growth. This extended growing season allows algae populations to expand, leading to a greater darkening of the ice sheet. The increased absorption of sunlight further accelerates the melting process, creating a feedback loop that amplifies the effects of climate change. The implications of this phenomenon are far-reaching. The accelerated melting of the Greenland ice sheet contributes to rising sea levels, threatening coastal communities worldwide. The proliferation of algae on the ice sheet is a stark reminder of the interconnectedness of Earth's systems and the urgent need to address climate change.